So generally, no one is doing the insulation coordinates study for now, and they are depending on some other tools. In ETAP also, I don't know. We are having this insulation coordinates study. They are doing in if your substations or with a high voltage levels like 400 kV or above 220 kV, then I would prefer to do this insulation coordination study, and because of your 400 kV lines, and also if the lines which are going out from your substations, and if they are traveling some far kilometers, okay, far kilometers, then it's required to do this insulation coordination study, because the effect of this black flash rate or CFO of the line, you have to check. This may influence on the such steepness on your system, which may affect the insulation levels, or which may change the levels of the insulation in your substation drastically. So I would prefer, if you are having a transmission lines greater than long transmission lines, more than 100 kilometers or 120 kilometers, and also if your substations is of a extra high voltage, ultra high voltage substations, then it's good to do the this insulation coordination study. Generally, the main reason is to select the cost-effective equipment in the substation. So let's check. Even though for high voltages is generally required, for low voltages may not be required, because in higher voltages there might be a chance of BSL also, which will also impact your insulation levels into a substation. Not only the BIL, because of the not only the lightning impulse, maybe the switching impulses also affect the most in your substation, in your system. So it's better to do the insulation coordination study for extra high voltages, not much needed for this. In Indian projects, we are not doing the insulation coordination study team. Generally, we are going ahead with the values that are tabulated in IEEE 1313. So we are taking the worst thing and we are doing that. And if you ask me, we are not at all doing the calculation of phase to ground and phase to phases also from this what we are discussing in the next class. Generally, in Indian projects, we are going with a standard way of placing the lightning arresters, the spacing, and between the equipment, all this standard. So if you ask me, they will say that yeah, you need to place the equipment 5 meters apart into 20 kV. So what is the reason? No one tell. So we, as a electrical design engineer, we should know we should provide a justification if anyone asks you. So today we discussed the phase to ground and phase to phase clearances. So how to calculate the phase to phase and phase to ground clearances. In our next class, we will see how to use these phase to phase clearances and phase to earth clearances to develop the layout. So I would request you to go through that IEEE 1427. I'm sharing to you. So that's a very quite good, interesting book, team, because this will give you a more chances for selection in the interviews team. Because generally, if in interviews, I have faced interviews, generally they will ask you that, so what is the clearances you are maintaining in 33 kV? So practically, if they ask me, I will say yes, because I have done the projects. So if I remember these things, so I can say that yes, sir. In Andhra Pradesh and Telangana states, we are maintaining the clearances of 1.5 meters per phase to phase clearances for 33 kV, and 4.5 meters phase to phase clearances for 220 kV. And if I am asking, and for the Karnataka projects, we used 1.2 meters for 33 kV and face-to-face clearances, and 4 meters for 220 kV. And in Madhya Pradesh, say 1.2 meters, and in 220 kV, even though in some projects I have used 3.8 meters. So these are different types of face-to-face clearances and face-to-earth clearances. Generally, you are seeing. So this will come with a practical. So if you've done the projects, you will get. But it's better to answer this question in other way that it's practically these are the cases, sir. But actually, it depends upon the BAL, BSL levels of my substation. The insulation, the face-to-face, the face-to-ground clearances is generally depends upon the BAL and BSL level of my substation. Where this BAL and BSL levels we are calculating from the insulation coordination study, or else the selected BAL and BSL levels of our substation. So to calculate this BAL and BSL levels, we have to comply with the standard of IEEE 1313, and to calculate this face-to-ground and face-to-face clearances from this BAL and BSL levels, we have to comply to the standard of IEEE 1427. No need to tell them. So we have to draw the single line diagram. We have to place the equipments, and we have to see the equipment, how much far it is from the lightning arrestor. No need, unless they ask you the flow. This is a simple explanation. Then he will come to know that, okay, he know what is the justification to have 1.5 meters face-to-face clearances for this project. I am saying that as a 33 kV, I have used it 1.5 meters as a face-to-face clearances. So why? What is the reason for that? Reason is this, sir. My 33 kV BIL level is 170 kVp. So 170 by 526 gives me 0.35 meters. So the minimum clearances to be maintained, face-to-face clearances maintained in 33 kV is 350 meters or 400 mm. Sorry, 400 mm. That is a minimum clearances to be maintained. But as I am constructing the substation outside the in the outside, so there might be a chances of wind flow, all this. So I am taking some margin. So it depends upon the respect to utility. I have used the face-to-face clearances as 1.5 meter in Andhra Pradesh on the Telangana states, and I have used the 1.5 meter spacing when I worked for Karnataka projects, and I have used 1.2 meters, and I have also used 1.5 meters when I am doing the projects for Rajasthan location. So this is the way of telling. Because you also know, because these are all you can see this all in a guide team. No need to see, what they will do is we are having one guide, CBIP guide. In that CBIP guide, I will share you that. Let me share you now itself. Give me a minute. I will show you that. All these outside engineers are complying to this guide only.